Hello, this is the second session of review problems for the GRE Quantitative Reasoning section. As a disclaimer, I will be presenting my own solutions to the following problems, but the problems themselves are owned by the Manhattan Review. To begin, let's start with the following. Consider the sequence given by A1, A2, A3, all the way up to AN, and continuing, such that A1 is equal to -2, A2 is equal to -5, A3 is equal to -4, and A4 is equal to 3. And AN, for any n greater than 4, is equal to AN minus 4. So, let's see what this actually means. We know that A1, A2, and A3, and A4 have the following values. So what is A5, for example? Well, given here, since 5 is greater than 4, A5 is going to be equal to A5 minus 4, which is equal to A1, and A1 is equal to -2. -2. So, similarly, we can say, what is A12? Well, A12, given here, since 12 is greater than 4, A12 is equal to A12 minus 4, which is equal to A8. But what is A8 equal to? Well, since 8 is greater than 4, we subtract 4 from it. So this is equal to A4. But we know what A4 is. That's equal to 3. So A12 is equal to 3 because it's equal to A4. So we can use this sort of reasoning in solving this problem. To start, we wish to compare the two quantities. Quantity A is the sum of the first 64 terms of the sequence, and quantity B is the sum of the first 98 terms of the sequence. So we can approach this from one of two ways. Firstly, we can actually sum the first 64 terms of the sequence and actually sum the first 98 terms of the sequence and just compare those two numbers. But that doesn't really make much sense here because there's so many terms and you have a limited amount of time on each question on the GRE. So instead what we can do is we can sum the first 4 terms. And something nice happens when we do that. So if we take A1 plus A2 plus A3 plus A4, we get -2 minus 5 plus 4 plus 3. But -2 minus 5 is equal to -7, and 4 plus 3 is equal to +7. So we get -7 plus 7. So this is equal to 0. So if we sum the first 4 terms, we get 0. And since the first 4 terms are equal to the second 4 terms, what I mean by that is we saw before that A4 is the same thing as A8. Similarly, A3 is the same thing as A7, A2 is the same thing as A6, and A1 is the same thing as A5. And we know that, this is A5. We know that from this rule here, that AN is equal to AN minus 4, for n greater than 4. So, since this rule holds, we see that A5 plus A6 plus A7 plus A8 is also equal to 0. Continuing this pattern out, we can say that the sum over the first 4 times n terms is equal to 0, where n is any number. So here, this is the first 4 terms, so n is equal to 1. If we did the first 8 terms, so n is equal to 2 here, we get A1 plus A2 plus A3 plus A4 plus these 4 numbers. But both of these sums are equal to 0, so the first 8 terms also sum to 0. So what we have to see is, are either of these numbers divisible by 4? If they are, then we know that the sum of the first that number of terms is equal to 0. And what we can see is that 64 is equal to 4 times n, where n is equal to 16. So quantity A, so QA, is equal to 0, because it's the first 64 terms of the sequence, And because 64 is divisible by 4, we just have a bunch of groups of 4 elements where each of the sums of those 4 elements is 0. So let's see if 98 is divisible by 4. Well, unfortunately, it's not, but we do know that 100 is divisible by 4. So 100 is equal to 4n, where n is equal to 25. So 100 is divisible by 4. And we know 98 is 2 less than 100. So if we wanted to see what the first 98 terms are, we add up the first 100 terms, and then we take off the last 2. Well, the last 2 would be equal to A3 plus A4. So what we get is 0 minus 4 minus 3 is equal to the first 98 terms, is equal to the first 98 terms. So that's equal to -7, because it's -4 minus 3. So quantity B is equal to -7. So we want to compare quantity A to quantity B. What we see is that quantity A is greater than quantity B. So the answer here is A. Next, the arithmetic mean of the list of numbers above is 4, and A and B are integers. So we have the following list given in this top left corner here. Then we know that the arithmetic mean is equal to 4. So that means that 4 is equal to 3 plus A plus 1 plus 9 plus B plus 3 divided by, well, how many are there? 1, 2, 3. There are 6 of them. So divided by 6, that's equal to 4. So if we multiply by 6 on both sides, we get 24 is equal to, well, 1 plus 9 is 10, 3 plus 3 is 16, so we get 10 plus 16, 10 plus 6 is 16, plus A plus B, so that means that A plus B is equal to 8. So now we have a constraint on the sum of A and B, and we wish to compare the median of the list to the mean of the list. So we already know that quantity B is equal to the mean, which is equal to 4. We're given that it's equal to 4. So we want to compare this to the median, and we wish to find the median. So you may think, because we have no other constraints on A and B besides this, we can't solve for both of them, meaning we can't find the true median. But this turns out to be just enough information to give us what we need. So consider the following cases. So let me get rid of this. Consider the following cases. Firstly, A is big and B is small. So in this case, since they're both integers, what I mean is that B is very negative. So it's like maybe -100, and A is very big. So maybe 108. So this is positive. And the reason that I chose 108 and 108 and -100 is that their sum is still equal to 8. So we have to require that A plus B is equal to 8. Then what we find is that the median of the list is the middle numbers of the list. Since we have an even number of digits here, we have 6 terms in the list. That means that the middle 2, the average of them, is equal to the median. So in this case, since B is very, very negative, it's the smallest element of the list. So we have B as the first element because it's the smallest. Then we would have 1, then 3, and 3, and then 9, and then A. So the middle of the list is the 2 3s. And the average of 3 plus 3, we have 3 plus 3 divided by 2. That's the average of the two of them. This is equal to 6 over 2, which is equal to 3. So the median here would be 3. So median is equal to 3. And what we see is that 3 is less than 4. So in this case, we already have an answer. We see that the mean is greater than the median, so that means the answer would be B. But this isn't the only case we can consider. Next, consider the case where A and B are equal to each other. Or if we don't do that, and instead we say, what if A is really small and B is really big, we get the same thing. It doesn't matter which one we chose to be big and which one we chose to be small. So that's just to note. Next, let's consider the case where we have A is equal to B, such that A plus B is equal to 8. Then we see that A is equal to 4, and so is B. Then we list out this list in increasing order of the elements. So first we have 1, and then we have 3, 3, then we have 2 4s from A and B, so 4, 4, and then we have 9. So the middle two elements here are now 3 and 4. But if we take the average of these two, which is 3 plus 4 over 2, we get 7 over 2, which is equal to 3.5. And what we find is that 3.5 is still less than 4, just like we found in the other case. So here the answer would still be B, but you may still not be convinced. You might say, what if we had A is equal to 3 and B is equal to 5? We still have A plus B is equal to 8, so let's list out the terms. Well, first we have 1, then we have the 2 3s, then we have A, which is 3, then we have 5, and then we have 9. But here we still have the middle two elements are 3. So the average of these two is 3 plus 3 over 2, which is equal to 3. So the answer is still B. And what you'll find is that no matter what numbers you choose for A and B, as long as A plus B is equal to 8, we find that the answer for the median is less than the mean. So in every case, we have that the median is less than the mean. So the answer here is B. Next, X is chosen at random from the set 1, 2, 3, 4, and Y is chosen at random from the set 5, 7, 9. We wish to compare the probability that X times Y will be even to the probability that X plus Y will be even. Well, we have two cases here. Firstly, we consider quantity A. Quantity A is X times Y, and we want that to be even. Well, X times Y is even if X and Y are even, or if X or Y is even. So all we need is that one of the two to be even. We could have both, but all we need is one of them. And that's, so for example, consider, X is equal to 2 and Y is equal to 1. 1 is odd, 2 is even, this is equal to 2. So an odd number times an even number is equal to an even number. And let's say it's 2 times 2. These are both even numbers. This is equal to 4. So an even number times an even number is equal to an even number. So all we need is one of the two to be even. So let's look at each list. For the X list, 2 out of the 4 elements are even. So X is even with probability 1/2, or 0.5, let's say. Then, if we look at the Y list, there are no even numbers in 5, 7, 9. So Y is never even. So the probability that X or Y is even, Y is never even, so we only care about what's the probability of X being even. And we already found that that probability is equal to 0.5. So the quantity A, that probability of x times y will be even, is just 0.5. That's the whole probability. Next, let's consider quantity B. So for B, we wish to see that x plus y is even. Now this occurs in one of two cases. One, so this occurs if x and y are even, or x and y are odd. So, and just to see this as an example, let's say we want the sum of two terms to be even. Let's choose 1 and 1. That would be both of them being odd. So 1 plus 1, both of these are odd. The sum of it is 2, and that's even. So two odd numbers add to an even number. Similarly, if we have two even numbers, so let's say 2 plus 2, that's equal to 4, which is even. So two even numbers add up to an even number. But if we have 2 plus 1, an even plus an odd number, this is equal to 3, which is an odd number. So an even plus an odd number is an odd number. So we need x and y to be even, or x and y to be odd. But what we found in part A is that the y list has no even numbers. So we can't consider this case anyways, because y is never even. So the whole probability of x plus y is even boils down to x and y both being odd. So what's that probability? So x is odd with probability, I'll call it PR here. Well, let's look at how many odd numbers there are. There's 1 and 3 in a list of 4. So that's a probability of 1/2, because 2 out of the 4 are odd. So this occurs with probability 0.5, or it occurs half the time, because half the elements are odd. And y is odd with probability, again I'll call probability PR. Well, let's look at it. It occurs with probability of how many elements are odd? All of them. So it occurs with probability 1. So we wish to find the probability that x and y are even. But if we want to say and, so if we're looking for both of them to be even, then this probability PR is equal to 0.5 times 1. So you multiply the two probabilities together if you want both of them to be true. So what is 0.5 times 1? That's just equal to 0.5. So the answer for B is 0.5. So let's compare that to A's answer. That's also 0.5. So the two quantities are in fact even, or they're equal to each other. So the answer here is C. Next, let 4 be less than 7 minus x over 3. We wish to compare the maximum value of negative 5 minus x to the maximum value of 2x. Well, let's solve for x in this inequality. So we have 4 is less than 7 minus x over 3. We can then multiply both sides by 3. So multiply both sides by 3. The 3's on the right cancel. So we get 12 is less than 7 minus x. Then add x to both sides. So we get x plus 12 is less than 7. Because if you add an x to the right, it cancels with the negative x, and then you get an x on the left. And then subtract 12 from both sides, and we get that x is less than negative 5. So this is something to keep in mind. X is less than negative 5. So let's find the maximum value of both of these quantities given that x is less than negative 5. Well, for A, we see if we distribute out the negative sign, negative 5 minus x is equal to x minus 5. Because the negative goes in, it cancels the negative on the x, and it gives 5 a negative. So we have x minus 5. Well, the maximum value of this is given when x is the least negative, because x is less than negative 5. That means if you look at a number line where this is 0, so if this is 0 and this is negative 5, x can be any of these values. So if we have x minus 5, we want x to be close to negative 5, because if it's all the way down here, we have a very, very negative number, minus 5. So that gives us a super negative number. So if we want the maximum value, we want the least negative it can be. So let's choose something that's very close to negative 5, but is still slightly less than it. So for example, let's choose x is equal to negative 5.000001. That's super close to negative 5, but it's not quite equal to it. And it's still less than negative 5. So if we plug in, then we get that a is equal to negative 10.000001. Now let's consider b. The same thing holds here as it did in a. If we want to make 2x as big as it can possibly be, we want to make x as big as it can be, which is as close to negative 5 as you can get. So let's choose the same x value we chose in a. If we chose x is equal to negative 5.000001, then b is equal to negative 10.000002. But we see there's a difference between these two quantities. And what we find is that a is actually greater than b. And that's because these are both negative numbers. And since this has a 2 and this has a 1, this is more negative by a very little amount than a is. So the answer here is that a is the greater quantity. So the answer is a. Finally, let's suppose that r, let me change colors, that r is less than q is less than p, which is all less than 0. So r, q, and p are all negative numbers, and they follow this relation. Then we wish to compare the quantity p over q to q over r. So let's just choose 2 instances of this, right? We can just pick random numbers such that this is satisfied and see what we get. So this is trial 1, and this will be trial 2. So if we choose trial 1, let's say we have r is equal to negative 10, and then q is equal to negative 9, and p is equal to negative 1. Right? This still satisfies these inequalities, and they're all negative. Then p over q is equal to, well, it's negative 1 over negative 9, which is 1 over 9, and q over r is negative 9 over negative 10, which is 9 over 10. But we can see q over r is the greater quantity here, right? Because 9 over 10 is greater than 1 over 9. So what we see is that b is bigger than a, because this is equal to quantity a, and this is equal to quantity b. So here b is the answer. But in trial 2, let's say we still have r is equal to negative 10. Well, let's make q closer to p. So now let's choose q is equal to negative 2, and p is equal to negative 1. Then a is equal to p over q, which is equal to 1/2. And b is equal to q over r, which is equal to negative 2 over negative 10, which is 2 over 10. But we can cancel out a 2 in the numerator and the denominator, and we get 1 over 5. So let's compare these two. 1/2 is greater than 1 over 5, right? So the answer here is actually A, whereas before it was B. So, since in these two trials we have different answers, we find out that we actually don't have enough information to determine the relationship. So, the answer here is D. And with that, we conclude the second session discussing review problems for the GRE Quantitative Reasoning section. Thank you.